Good morning, students. Let us start our class plus one. We start with our third chapter, Trigonometry, which is one of the important chapters in your class plus one. In first lecture, we will learn about measurement of angles and trigonometric functions. First of all, let us discuss what is an angle. The angle is defined as the amount of revolution that the revolving line undergoes with respect to its initial position. Angle is amount of revolution that the revolving line, here OB is your revolving line, undergoes with respect to initial position. OA is its initial position. Here the line OB revolves through an angle theta. The angle is positive if it is traced by revolving the line in anti-clockwise direction. Angle is positive if it is measured in anti-clockwise direction. This is your anti-clockwise direction. You all know very well about anti-clockwise direction, opposite to that of hands of clock. And negative if it is covered in clockwise direction. If you measure angle in clockwise direction, then it is negative. This is your clockwise direction. Next is measuring of an angle. You all know one right angle is equal to 90 degrees. One right angle is equal to 90 degrees. And 1 degree equal to 60 minutes. We denote the minute by dash, by putting dash on 60. 60 minutes is equal to 1 degree. And 1 minute is equal to 60 seconds. For seconds, we put double dash. One right angle is equal to pi by 2 radian. This is new thing for you. Radians. Angle can be measured in degree or in radian. So one right angle is equal to pi by 2 radian, or we can say that 90 degree equal to pi by 2 radian. From here we also conclude that 180 degree equal to pi radian. As I have told, 90 degree equal to pi by 2 radian. So multiplying both by 2, 90 into 2, 180. Pi by 2 into 2, pi radian. So 180 degree is equal to pi radian. Similarly, 360 degree equal to 2 pi radian. We summarize these results as relation between degrees and radians. Radian measure. If we have degree measure and we have to find radian measure, we multiply our degree measure with pi by 180 and we get radian measure. And if we have radian measure, we want to convert it into degree measure, then we multiply our radian measure with 180 by pi. Let us take some examples. Conversion of some angles from degree into radians. 30 degree. Now let us convert 30 degree into radians. We have degree measure 30 degree. So we multiply it by pi by 180. Pi by 180 into 30. It becomes pi by 6. So 30 degree is equal to pi by 6 radians. Next 60 degree. Pi by 180 into 60. Pi by 3. So if we want to convert degree into radian, we multiply it by pi by 180. Similarly 45 degree. 45 into pi by 180. We get pi by 4. 120 degree. Pi by 180 into 120. 2 pi by 3. You can easily simplify these. 270 degree and so on. Next is conversion of some angles from radian into degrees. Now we have radian measure. We have to convert it into degree measure. 2 pi by 3. 2 pi by 3 is our radian measure. We have to convert it into degree measure. So to convert radian into degree, we multiply it by 180 by pi. 180 by pi into 2 pi by 3. After simplifying, we get 120 degree. Next is pi by 4. 180 by pi into pi by 4. 45 degree. Next is 7 pi by 6. 210 degree and so on. So our first question is, find the radian measure corresponding to the following. Now we have degree measure. We have to convert it into radian measure. So first is 35 degree. We all know 180 degree equal to pi radian. 180 degree is equal to pi radian. So 1 degree equal to pi by 180. And 35 degree is equal to pi by 180 into 35. After simplifying, we get 7 pi by 36 radians. Very simple. For next question. Next question is minus 45 degree 20 minutes. So first we have to convert minutes into degrees. We know 60 minutes equal to 1 degree. And 1 minute equal to 1 by 60. So 20 minutes is equal to 1 by 60 into 20, which is equal to 1 by 3. 45 degree 20 minutes. First, let us take only positive value. 45 degree 20 minutes. 45 plus, we just converted 20 degree into 20 minutes into degree, that is 1 by 3. So we write it as 45 plus 1 by 3. After simplifying, we get 136 by 3 degree. Is it clear? Now our question is minus 45 degree 20 minutes. So we write it as minus 45 degree 20 minutes is equal to minus 136 degree 136 by 3 degree. Now we have to convert it into radian. So we multiply it by pi by 180. Minus pi by 180 into 136 by 3. After simplifying, we get minus 34 pi by 135 radians. This is our answer. Next is 47 degree 30 minutes. Same. Again, we know 60 minutes is equal to 1 degree and 1 minute equal to 1 by 60. 30 minutes is equal to 1 by 60 into 30, which is 1 by 2. So 47 degree 30 minute can be written as 47 plus 1 by 2. After simplifying, we get 95 by 2 degree. Now we have to convert it into radians. Procedure is same. 95 by 2 degree is equal to pi by 180 into 95 by 2. After simplifying, we get our answer 19 pi by 72 radians. I think it is clear to all of you. Okay, move on to our next question, which is now we have to find the degree measure corresponding to following radians. So first example is very important. We know pi radian equal to 180 degree. We always start from this concept. If we want to find the degree measure, we write it as pi radian equal to 180 degree, or if we want to find the radian measure, we write it as 180 degree equal to pi radian. So you always start from here. Pi radian equal to 180 degree. 1 radian equal to 180 by pi. Now we have to convert 11 by 16 into degrees. 11 by 16 radian into degrees. 11 by 16 radian equal to 180 by pi into 11 by 16 degree. After simplifying, we put here the value of pi, which is 22 by 7. Substituting the value of pi 22 by 7, we get 180 by 22 into 7 into 11 by 16. On simplifying, we get 315 by 8 degree. This is not our answer. 315 by 8 degree. We have to simplify this. So it can be written as this. In mixed fraction. Now 39 is degree, but 3 by 8 is in fraction. After degree, we use minutes. After minutes, we use seconds. Smaller units. So 39 degree plus 3 by 8 into 60. Because we all know 1 degree is equal to 60 minutes. So to convert 3 by 8 degree into minutes, we multiply 3 by 8 with 60. On solving, we get 39 degree plus 45 by 2 minutes. We have to simplify it further. It becomes 39 degree plus 22 1 by 2 minutes. Now we have to convert 1 by 2 minute into seconds. So we can write it as 39 degree plus 22 minutes plus 1 by 2 into 60 seconds. Again same concept. 1 minute is equal to 60 seconds and half minute is equal to half into 60 seconds, which turns out to be 30 seconds. So after simplification, we get 39 degree plus 22 minutes plus 30 seconds. On combining, we can write our answer 39 degree 22 minutes and 30 seconds. Everything is clear? Okay, move on to next question. 5 pi by 3. We have to convert it into degrees. We know pi radian equal to 180 degree, 1 radian equal to 180 by pi, same. So 5 pi by 3 radian is equal to 180 by pi into 5 pi by 3. We can cancel pi in numerator and denominator and 180 with 3. So our answer is 300 degrees. Very simple. 300 degrees. We convert 5 pi by 3 into degrees, which is our answer 300 degrees. Now, one important result. Theta equal to L by R, where theta is angle in radians, L is length of arc, and R is radius of circle. This is your circle. We have a circle with center O. O is initial line, OB is your revolving line, AB is length of arc, that is equal to L, OA is radius or OB is radius, R equal to R, and angle AOB equal to theta. So theta is equal to L by R. Or we can say that number of radians in angle AOB is equal to arc AB by radius. Here we measure angle in radians. If we have angle in degrees, firstly we have to convert it into radians. In our questions, if we have angle in degrees, if we are given angle in degrees, firstly we convert it into radians and then proceed on. Find the angle in radians through which the pendulum swings if its length is 75 centimeter and tip describes an arc of length 15 centimeter. Now we have to find an angle through which the pendulum swings if its length is 75 centimeter. Now the length of pendulum is 75 centimeter. Here length of pendulum is our radius and tip describes an arc of length. Arc of length is length of arc 15 centimeter. So let us find out our angle. Here R is equal to 75 centimeter and L equal to 15. We know theta is equal to L by R. This gives theta equal to 15 by 75. 15 is your length of arc and R is your radius. On solving, we get our answer 1 by 5 radians. Very simple. 1 by 5 radians. Okay, move on to our next concept, which is trigonometric functions. Very important topic. In this, we will discuss about trigonometric functions. Let us consider 4 quadrants. First, second, third and fourth. You all know about these quadrants. First quadrant, second quadrant, third quadrant and fourth quadrant. 90 degree, 0 degree, 180 degree, 270 degree. We move on in anti-clockwise direction. 0, 90, 180, 270, 360. We all know 0 and 360 are at same place. You all know about trigonometric functions. There are 6 trigonometric functions: sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. Actually, the full names are sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. In first quadrant, I have written all. All means all the trigonometric functions are positive. In second quadrant, I have written sine theta positive and cosecant theta positive. Rest are negative. In second quadrant, only sine and cosecant, its reciprocal. Sine theta and its reciprocal cosecant theta is positive. Other four are negative. In third quadrant, tan theta positive and cot theta positive, other four negative. In fourth quadrant, cos theta positive and secant theta positive. To learn this concept, we can use this also. All school to college. All is for first quadrant. You can use A, or you can use the whole word all positive. Second is school. From school, you can use the first word S. S denotes sign also. So sign positive, cosecant, its reciprocal is always positive. Next, third quadrant, 2. You can use T. T is for tan also. So tan positive, its reciprocal, cot theta is also positive. And fourth, college, all school to college, C. C is for cos theta. If cos theta is positive, its reciprocal is also positive, which is secant theta. Up to this, I think everything is clear to you. Now we start our operations on this table. First is sine 90 minus theta. You all know that it is equal to cos theta. But you do not know how it comes. You just learned it in your previous class, 10th class. Sine 90 minus theta, cos 90 minus theta, sine theta, up to so on. But there is a concept how it changes to cos theta. Let me introduce that concept. On 0 and 180, we do not change sine into cos, cos into sine. But on 90 and 270, we change sine to cos and cos to sine, tan to cot, cot to tan, secant to cosecant, cosecant to secant. We take a lot of examples. 90 and 270 lies on vertical line. 90 and 270 lies on vertical line. So you nod your head as you are saying yes. You can nod your head as you are saying yes along the vertical line. 90 270. 90 and 270 means change. Yes. Yes, we have to change. But at 180 and 360 or 0? Nod your head as no. No. At 90 to 270, we nod our head up down. But at 180 and 360, we nod our head left to right, right to left. No. So 90 on 90 and 270, we have to change. Yes. But at 180 and 360, we do not change. No. Now come to our concept. Sine 90 minus theta. Now you have to see three things. First of all, concentrate at the angle 90 minus theta. 90 minus theta means you came in first quadrant. 90 minus theta. Let us suppose theta is equal to 5 degree. So 90 minus theta is 85 degree. 85 degree lies in first quadrant. First of all, you have to note in which quadrant we are talking about. 90 minus theta. 90 minus theta is your first quadrant. Okay, first thing is we have to check the quadrant, and second we have to check whether we are adding or subtracting from 90 or 180 or 270 or 360, because I have already told you that at 90 and 270 we have to change. So second point is we have to see 90 plus or 90 minus, 180 plus or 180 minus, what is going on. Okay. Second thing is clear. Third, you have to check the sign of the trigonometric function. Here we are in first quadrant. In first quadrant all are positive, so we have no tension of positive or negative. Now again I am discussing it. 90 minus theta means first quadrant. At 90 we have to change, and sign is positive. For sign is positive in first quadrant, so our answer is cos theta, because we have to change. In first quadrant all are positive, so there is no negative sign. Answer is cos theta. Sin 90 minus theta is a cos theta. Let us take another example. Cos 90 minus theta. 90 minus theta. 90 minus theta means first quadrant. At 90 we have to change. Yes. Nod your head. Yes. We have to change. Cos. Cos is positive or negative in first quadrant? In first quadrant all are positive, so cos is also positive. But we have to change because we are subtracting theta from 90. We have to change. So our answer is sin theta. Clear? Next is sin 90 plus theta. Now we move on to the second quadrant, 90 plus theta. This is our second quadrant. Firstly we see which quadrant? 90 plus theta, second quadrant. Clear? Now we are adding theta into 90, so we have to change. Third is we have to see the trigonometric function sine. Sine is positive or negative in second quadrant? Sine is positive. Sine theta and cosecant theta are positive in second quadrant. So our answer is cos theta. We have to change sine into cos, sine theta into cos theta. Then we add or subtract in 90. So, but the answer remains positive. because sine theta is positive and cosecant theta is positive in our second quadrant. Next example, cos 90 plus theta. Listen it carefully. Cos 90 plus theta. Now 90 plus theta. Again second quadrant. 90 plus theta, second quadrant. We are adding in 90, so we have to change also. Cos. Cos is positive or negative in second quadrant? Cos is negative in second quadrant. Cos is negative, so our answer is minus sine theta. Minus sine theta. Because we have to change cos into sine, but we have to check negative or positive. Cos is negative in second quadrant, so we put negative before sine theta. Cos 90 plus theta is equal to minus sine theta. Next, tan 180 minus theta. Now this is tan 180 minus theta. 180 minus theta means second quadrant. 180 minus theta, second quadrant. At 180 and 360, we do not change our trigonometric function. No change. 180 minus theta, second quadrant. At 180, we do not change our trigonometric function. Tan. What is tan in second quadrant? Tan is negative. So our answer is minus tan theta. Minus tan theta. Because tan is negative in second quadrant. So we put negative sign before our answer. Minus tan. Next is cot 180 plus theta. 180 plus theta. Third quadrant. Third quadrant. Clear? Now we are adding theta into 180. At 180, we do not change our trigonometric function. Cot 180 plus theta, third quadrant, no change. In third quadrant, cot theta is positive. So our answer is cot theta. Next is sine 270 minus theta. 270 minus theta. At 270 minus theta, this is your third quadrant. 270 minus theta is your third quadrant. At 270 and 90, we have to change our trigonometric function. So 270 minus theta is third quadrant. We have to change. Firstly, we have to check the sign. Here sine theta is negative in third quadrant. So our answer is minus cos theta. Because sine theta is negative. So our answer is minus cos theta. Next example, cos 360 minus theta. 360 minus theta. 360 minus theta is our fourth quadrant. This is our fourth quadrant. And at 360, we do not change our trigonometric function. In fourth quadrant, cos theta is positive. So our answer is cos theta. Simple. Another example. Sine minus theta. Sine minus theta. Minus theta. Minus theta means now we start moving in clockwise direction. Clockwise direction is 0 to 270, 180, 90, again 0. Opposite direction, clockwise direction. So when minus theta is written, then it lies in fourth quadrant. Whenever you see minus theta, just think of fourth quadrant. In fourth quadrant, cos theta and secant theta are positive. Rest are negative. Now in our question we have sine. Sine minus theta, which is negative, minus sine theta. But cos minus theta, again fourth quadrant. In fourth quadrant cos theta is positive, so our answer is cos theta. Sine 270 plus theta. 270 plus theta. Which quadrant? Fourth quadrant. 270 plus theta. Fourth quadrant. At 270 we have to change. Now what is sine theta in fourth quadrant? Positive or negative? Sine theta is negative. So our answer is minus cos theta. Minus cos theta. Next example. Cos 360 plus theta. 360 plus theta. After completing one revolution, we are back in our first quadrant. 360 plus theta. After one rotation, after one revolution, we are back in our first quadrant. In first quadrant, all are positive, and at 360, we do not change our trigonometric function. So answer is cos theta. Next is sine 180 plus theta. Sine 180 plus theta. 180 plus theta is our third quadrant. At 180, we do not change, and sine theta is negative in third quadrant. So our answer is minus sine theta. Cos 180 plus theta. 180 plus theta, again third quadrant. Cos theta is negative. So our answer is minus cos theta. This is very important table. You have to revise it again and again. If this table is clear to you, then half of the trigonometry is clear. So it is very important. Revise it again and again. Now this is our session today. I finish with this session. We will discuss examples on this topic in our next lecture. So bye.